Hello students, welcome to DOPA live class. So let us see how many of you are joined. Let us introduce ourselves. My name is Shafeer Ambatt. So please comment in the chat box in the live chat. Okay. Let me see who all are online. I know this is our first live class, right? This is our first live class. So let me get to know who are the students which have came to the class first. So today our aim is to do an interactive session. Okay, to do an interactive session about laws of motion. So I know that you have studied laws of motion, the video lectures. You have studied through the video lectures of laws of motion and also attended an exam. Clear? So please let me know the feedback first. Students, let me know the feedback. How was the class? Was it helpful for you? Were you able to understand the concept? Were you able to understand the problems? Most importantly, the method of solving questions. Okay, not just in laws of motion, in general, all subjects of DOPA classes. Okay, so let us wait for a few more students to join. A few more of your classmates are yet to join. So the scheduled time is 10 o'clock. So the NEET exam was finished a few weeks ago. You may not have seen the question paper, but the overall response was, the exam was very easy. For almost everyone, the exam was very easy. Okay, so from that we can understand that, from that we can analyze that. Okay, so from that we can actually okay, I see that 23 students are online now. 23 students have joined. Let us wait for a few more of your friends to join. 27 is online now. Okay, so your classmates are here. So once again, welcome to DOPA live class. Okay, so all future doctors, this is me, Shafeer Ambatt. Okay, so I'm your physics teacher today. We are here to discuss about laws of motion. So you studied laws of motion. I hope you have studied laws of motion and you have completed one examination also. You have practiced some questions, you completed one examination. You had some doubts, you had some misconceptions, etc. And we will clear that in today's class. Okay, so I have included some of your doubts from your exam in this class and also a few more questions, a few set of good quality questions also. So this will be an interactive session. You have to solve the question. I will wait for you to solve. Then you can ask your doubt from the questions or from any part of laws of motion. You can ask it today. Okay. So shall we begin? Just let me know in the chat box. Shall we begin or not? All of you please send a message and let me know. Are you ready? So like I said, the previous NEET exam, the very recent NEET exam, it tells us that in physics, especially in physics, the questions asked in physics was very basic. Okay, the questions asked in physics are very basic. They are not going into detail, or they are not going for advanced or complicated questions. So if you have covered all the theory, all the important sections, then you will be able to comfortably answer majority of the questions in NEET exam. Compared to other exams like JEE mains or advanced, NEET physics in NEET exam is comparatively easier. Okay. So our goal is to reach as many topics as possible, as many variety of questions as possible. So let me start with a question from your exam. I think one of you asked this as a doubt. Okay, so this is our question here. You can read the question and try to answer it. Think on your own. I'll give you a few minutes. Please answer the question. And let me know the answer in comment box. Let me know the answer in comment box. A man of 60 kilogram mass is standing on a spring balance inside a lift. Okay, if the lift falls freely downwards, then the reading of the spring balance will be. If the lift falls freely downwards, then the reading of the spring balance will be. What will be the answer? Okay, come on, I'm waiting for you. Please, I don't see that. Okay, so answer is 0. A few of you are answering it as 0. Is 0 the answer? We know about the spring balance, right? What is the advantage? What is the working principle of a spring balance or any balance? Okay, spring balance or any balance. So imagine this is the balance that we use in our homes to measure ourselves, to measure the mass of ourselves. Okay, is this class only about discussing questions? No, it is about asking doubts also. So I will discuss theories also in between. You can ask your doubts. So Explorer Dude has asked whether this class is about discussing questions or not. So this class will have questions. This class will have doubt clearance also. You can ask your doubts. So here the answer is 0. Correct answer. Many of you have answered. How do we get that answer? I have told you in spring balance or in any balance, what is measured in the balance? What is measured in the balance? It is the normal reaction. The balance or the weighing scale is able to measure the normal reaction. So when you are standing on the scale, imagine if the reading is 60 kilogram. Imagine if the reading is 60 kilogram. Imagine the reading is 60 kilogram because your weight is acting on the scale. Your weight is acting on the scale and the normal reaction is acting upwards. And you are not moving in any direction, therefore n is equal to mg, and that n is being shown here. The normal reaction is being shown in the weighing scale. Understood? Clear? So that is why when your friend is standing on the weighing scale and without him seeing that, you actually press on the weighing scale. Okay, you actually press on the weighing scale and his mass will be, or the reading will be increased. Even though you are not actually standing on the weighing scale, with just pressing using your hand, you can increase the reading. Understood? So the normal reaction is actually displayed on the weighing scale. If it is a weighing scale, normal weighing scale, or a spring balance, that is the same case. Clear? So now it is the lift is falling freely. The lift is falling freely. The lift is falling freely, which means there is no effective G. Okay, there is no effective G. There is no normal reaction. There is no normal reaction of the person on the scale. There is no normal reaction because everything is now falling down. Everything is now falling down with the same acceleration, that is acceleration due to gravity, and there is no normal reaction. The person has to exert a force on the scale so that the scale can feel a normal reaction backwards and display the reading. So the answer is 0. Very good for those who answered. I hope all of you understood that, right? I hope all of you understood the question. Those who found this question a bit confusing in the exam, let me know if you have understood it now. Okay. Clear? So let us go to the next question. Okay, so while doing questions, we are discussing the theory also. So in the previous question, we discussed the normal reaction. Okay, we discussed the principle of weighing scale. How weighing scale is able to display the reading. Okay, on what principle? Okay, if that is clear, then let us please do the next question. So this also was asked in your examination and some of you did not get this answer. Let us see how it is. So two masses, A and B of 10 kg and 5 kg. Okay, A and B of 10 kg and 5 kg respectively are connected with a string passing over a frictionless pulley fixed at the corner of a table. The coefficient of static friction of A with the table is 0.2. Okay. Coefficient of static friction on the table is equal to 0.2, the minimum mass of C that may be placed on A to prevent it from moving. The minimum mass of C that may be placed on A to prevent it from moving. Okay, so let's see who will answer this first. Okay, so one thing I have to tell you is you can make mistakes. All of you just attempt the question and shout the answer that you have got. Okay, make those mistakes now and understand from those mistakes. That is what this session is for. If you have any particular doubts regarding any question or topic, you can ask that in between. No problem with that. Answer is A. One of you is answering it as A. 15 kilogram. Okay. Yeah, I think some of you are answering it right. Then let us see. See here the driving force of this entire system. See the mass of A and C. Weight of A and C is balanced by the normal reaction. It is balanced by the normal reaction. And the driving force of this entire system is the weight of this. Weight of the block B. Okay, the driving force of this entire system is the weight of the block B. Okay, clear. And that is the driving force of this entire system. Now the minimum mass of C that may be placed on A to prevent it from moving. Okay, so what is the force, driving force? Driving force is equal to 5G. Okay, so 5G is acting here, 5G is acting throughout. Okay, and we need to find the mass of C. Mass of C is equal to how much? Okay, so some of you are requesting to speak in Malayalam. Okay, I can explain this question in Malayalam also. So, ഇവിടെ നമുക്ക് 3 മാസ് ഉണ്ട് A, B, C. Okay, 3 മാസ് ഉണ്ട് A, B, C. Bയുടെ മാസ് എന്ന് പറയുന്നത് 5 കിലോഗ്രാം ആണ്. A is 10 കിലോഗ്രാം. A എന്ന് പറയുന്നത് 10 കിലോഗ്രാം ആണ്. ഓക്കെ, നമുക്ക് കണ്ടുപിടിക്കേണ്ടത് എയുടെ മേലെ നമ്മൾ C കൂടെ വെച്ച് കഴിഞ്ഞാൽ, എയുടെ മേലെ നമ്മൾ C എന്ന ഒരു ഒബ്ജക്റ്റ് കൂടെ വെച്ച് കഴിഞ്ഞാൽ ഈ A and C എന്നുള്ള സിസ്റ്റം എന്ത് ചെയ്യാൻ പാടില്ല? മൂവ് ചെയ്യാൻ പാടില്ല. ഓക്കെ, ദാറ്റ് ഇസ് ദ കണ്ടീഷൻ ഹിയർ. A എന്നുള്ളത് മൂവ് ചെയ്യാൻ പാടില്ല. ഇവിടെ ഫ്രിക്ഷൻ ഉണ്ട്. എവിടെ ഫ്രിക്ഷൻ ഉണ്ട്? എക്കും ടേബിളിനും ഇടയ്ക്ക് ഫ്രിക്ഷൻ ഉണ്ട്. കോഎഫിഷ്യൻ്റ് ഓഫ് ഫ്രിക്ഷൻ 0.2 ആണെന്ന് തന്നിട്ടുണ്ട്. ക്ലിയർ? അങ്ങനെയാണെന്നുണ്ടെങ്കിൽ ഈ 3 സിസ്റ്റത്തിൽ, ഈ ടോട്ടൽ സിസ്റ്റത്തിലെ 3 മാസ് ഉണ്ട്. അതിലെ ഡ്രൈവിംഗ് ഫോഴ്സ് എന്ന് പറയുന്നത് ആരാണ് ഈ സിസ്റ്റത്തിനെ താഴേക്ക് വലിച്ചുകൊണ്ട് കൊണ്ടുപോകുന്നത്? 5 kgയുടെ വെയിറ്റ് ആണ്. Weight of 5 kg is pulling this entire system in one direction. Okay, so due to friction, there will be friction between A and table. There will be friction between A and table, and that friction should be able to prevent the motion. അതായത് എക്കും ടേബിളിനും ഇടയ്ക്ക് ഉണ്ടാകുന്ന ഫ്രിക്ഷൻ എന്ത് പ്രിവെൻറ്റ് ചെയ്യണം? എയുടെ മോഷനെ പ്രിവെൻറ്റ് ചെയ്യണം. ഓക്കെ, എയുടെ മോഷനെ പ്രിവെൻറ്റ് ചെയ്യണം, എക്കും ടേബിളിനും ഇടയ്ക്കുള്ള ഫ്രിക്ഷൻ. ആൻഡ് ഹൗ മച്ച് ഇസ് ദാറ്റ് ഫ്രിക്ഷൻ? ഫ്രിക്ഷൻ വി നോ ദ മാക്സിമം വാല്യൂ ഓഫ് ഫ്രിക്ഷൻ എന്ന് പറയുന്നത് എത്രയാണ്? mu into n. The maximum value of static friction is equal to mu into normal reaction. The maximum value of static friction is equal to mu times normal reaction. Okay, mu times normal reaction. Clear? So here the normal reaction will be equal to 10 plus mass of C. C കൂടെ നമ്മൾ എയുടെ മേലെ വെക്കുകയാണെങ്കിൽ, when we are keeping C also on top of A, the total normal reaction will increase. Okay, so this should be equal to the driving force. Okay, this should be equal to the driving force. Clear? Okay, so let's see what is the value of mu. Value of mass of C. C യുടെ mass എത്രയാണെന്ന് നോക്കാം. mc is equal to 50. So mu is equal to 0.5. Mu is equal to 0.2 into 10 plus mc, that is equal to 50. Okay. So 10 plus mu c is equal to 50 divided by 0.2, that is equal to mu into total is equal to friction will be acting in this direction. Friction will be acting below A. It is between A and the table. Okay, in the opposite direction. In the opposite direction. Okay. Clear? So friction is equal to mu times normal reaction, and the normal reaction here is equal to total mass. What is the total mass here? 10 plus mc, right? Okay. Yeah, there should be a G also here. Okay, in the normal reaction there should be a G also. Therefore here we will have a G, and here we have 5 into G here. And the G will cancel, and the G will cancel, and then in the next step we can write 0.2 into 10 plus mc is equal to 5, or 0.2 or 10 plus mc is equal to 10 plus mc is equal to. Some of them are answering 15. Okay, let us see the answer again. Let us check the answer again. So idea here is that mu times normal reaction. Okay, mu times normal reaction should be equal to the driving force. Then the A will not be able to move. Body A will not be able to move. So that is equal to 0.2 into 10 plus mc into G is equal to 5 into G. Okay, we can cancel G. Therefore 0.2 10 plus mc is equal to 5 divided by 0.2. I think there is something wrong here. Two masses A and B, 10 kilogram, 5 kilogram, are connected with a string, and minimum mass of C, that may be placed on A to prevent it from moving, right? Yeah. So okay, many of you got 15 as the answer, right? Many of you got 15 as the answer. Let us recheck the answer here. Let us recheck if there is any error in the problem, or in the method, or in the solving technique. Okay. So what is the correct answer here? 15. So A and C together. A and C together will have 10 plus mc into G will be their mass, their weight, and normal reaction will be equal to the 10 plus mc into G. Okay, therefore frictional force on the table, friction between A and table will be equal to mu times 10 plus mc into G. Okay, therefore 0.2 into 10 plus m into G is the frictional force that will be acting, that will be trying to oppose the relative motion, that will be trying to oppose the relative motion. Okay, and only 50 Newton, this is equal to 50 Newton. 50 Newton is acting in the, 50 Newton is our driving force. 50 Newton is our driving force. Okay. Newton. Therefore, they should be equal. 0.2 into 10 plus mass into G should be equal to 50 Newton. Okay, 10 plus mass should be equal to 50 Newton. So when you cancel it, you get 5 here. When you cancel it, you get 5, and 0.2. So 10 plus mass will be equal to 5 divided by 0.2, that is coming out as 10. Okay, I think there is some error in the problem, error while I'm doing it. Okay, those who found the correct answer as 15, can you just let me know if what is the error in my solution? Those who got the answer as 15, can you let me know what is the problem here? Okay, so from the solution, I think the answer is coming out to be, from here we can say 10 plus m is equal to 10 and m is equal to 0, I think. Okay, m is getting as 0, which means the mass of 10 is enough. Mass of 10, the minimum mass of C that may be placed on A to prevent it from moving, we don't have to 50 by 2. Okay, so 50 divided by 2, I think. Okay, 50 divided by 2, I think, yeah, that was the mistake here. In the last step. Yeah, this should be, okay, sorry, this should be 25. Yes, it should be 25, and hence m is equal to 15. Okay, so that was a small mistake in that division step. Okay, I hope all of you understood the theory here. Clear? Okay, that was a small mistake. Anyway, I hope all of you understood the theory. So here the theory is again, the limiting friction, the static friction value is preventing A from moving along with B. Okay, clear? So if you have any of you, if you have doubts in that question, you can let me know. So here is another question. This is also from your exam. This is also from your exam. Okay, this is also from your exam, and some of you asked this as a doubt. Some of you have asked this as a doubt. Let's see how we can solve this. A uniform rope of length L. A uniform rope of length L. So all of you please try to attend and answer it as soon as possible. Try to answer it as soon as possible. We have a table here. We have a table here, and a rope is lying like this. Okay, a table here and a rope is lying like this. Maximum length L1 of the part of this rope which can overhang from the table without sliding down. Again, the same principle. It is the same principle as the previous question. Okay, നമ്മൾ കഴിഞ്ഞ ക്വസ്റ്റ്യനിൽ ചെയ്ത അതേ സംഭവം തന്നെയാണ് ഇവിടെ അപ്ലൈ ചെയ്യേണ്ടത്. ഇത് നിങ്ങളുടെ എക്സാമിന് ടെസ്റ്റിന് ചോദിച്ച ക്വസ്റ്റ്യൻ ആയിരുന്നു. ആർക്കോ കിട്ടിയില്ലെന്ന് ഡൗട്ട് പറഞ്ഞു. ഓക്കെ, ദാറ്റ് ഇസ് വൈ വി ആർ ഡിസ്കസിങ് ദിസ് അഗൈൻ. നമ്മൾ നേരത്തെ ചെയ്ത ക്വസ്റ്റ്യൻ്റെ സെയിം പ്രിൻസിപ്പിൾ ഇവിടെ അപ്ലൈ ചെയ്ത് നോക്കുക. ടോട്ടൽ ലെങ്ത് എന്നുള്ളത് L ആണ് ടോട്ടൽ ലെങ്ത്. L ഇസ് ദി ടോട്ടൽ ലെങ്ത്. അതിൻ്റെ അതിലെ എത്ര പാർട്ട് വരെ ഹാങ് ചെയ്യാൻ പറ്റും. അപ്പോൾ നിങ്ങൾക്കറിയാം, നമ്മളൊരു ടേബിളിൻ്റെ വെൻ വി ഹാങ് എ റോപ്പ് ഓൺ ദി എഡ്ജ് ഓഫ് എ ടേബിൾ, താഴേക്ക് തൂങ്ങിക്കിടക്കുന്ന അല്ലെങ്കിൽ ഹാങ് ചെയ്ത് കിടക്കുന്ന പാർട്ട് കുറച്ച് അധികമാണെന്നുണ്ടെങ്കിൽ ആ റോപ്പ് എന്ത് ചെയ്യും? കംപ്ലീറ്റ്ലി താഴേക്ക് വരും. ഓക്കെ, ആ റോപ്പ് കംപ്ലീറ്റ്ലി താഴേക്ക് വരും. അങ്ങനെ താഴേക്ക് വരാതിരിക്കാൻ വേണ്ടിയിട്ടുള്ള ആ മാക്സിമം ലെങ്ത് ആണ് ചോദിച്ചിട്ടുള്ളത്. താഴേക്ക് വരാതിരിക്കാൻ വേണ്ടിയിട്ടുള്ള മാക്സിമം ലെങ്ത്. ഓക്കെ, താഴേക്ക് വരാതിരിക്കാനുള്ള മാക്സിമം ലെങ്ത്. എത്രയായിരിക്കും? സോ നിങ്ങൾക്ക് ഇമാജിൻ ചെയ്യാം ദി ടോട്ടൽ മാസ്. You can imagine that the total mass of the rope is m. Okay, and the length is L, and length is given as L. Therefore, mass per length is equal to m divided by L. Mass per length is equal to m divided by L. 25 is not in the option. 25 is not the answer. Answer is 15. 25 is not the answer. Answer is 15. 25 is the sum of both of A and C. 25 is the sum of the masses of both A and C. Sum of mass of A is 10, therefore the remaining mass is 15. Okay. So let's see who can solve this first. Let us see who can solve this question first. Yes, Neha said the correct answer in the previous question. 25 minus 10 is equal to 15. Yes. What about this question? Which option is correct? A, B, C or D? A, B, C or D? Which option is the correct option? A, B, C or D? How much maximum length of the part of this rope that can overhang? Option C, one of you got the answer as option C. How do we get this? It is the same logic. Okay, it is the same logic. So you have masses like this, you have masses like this. This is L1, this is L1, and this is the remaining part. This is the remaining part. Okay, that is the remaining part. And coefficient of friction here is mu. Coefficient of friction here is mu. Therefore, again, like the previous question, the mass or the weight of the hanging part, തൂങ്ങി കിടക്കുന്ന റോപ്പിൻ്റെ വെയിറ്റ് ആണ് ഇവിടുത്തെ ഡ്രൈവിംഗ് ഫോഴ്സ്. ദാറ്റ് ഡ്രൈവിംഗ് ഫോഴ്സ് എന്ത് ചെയ്യണം? ഈ ടോട്ടൽ മാസിനെ കൊണ്ട് വലിച്ചുകൊണ്ട് പോകണം. ഓക്കെ, ക്ലിയർ? അങ്ങനെയാണെന്നുണ്ടെങ്കിൽ നമുക്ക് എങ്ങനെ അത് എഴുതാൻ പറ്റും? സോ മാസ് ഓഫ് ഹാങ്ങിങ് പാർട്ട് is equal to mass divided by length. Total mass by total length into the required length. Okay, therefore weight is equal to mg by L into L1. So എന്താണ് നേരത്തെ കോൺസെപ്റ്റ്? What was the concept in the previous question? So the driving force should be equal to the friction. And therefore this part will be stationary. The part which is on the table will be stationary because its force is balanced by friction. Okay, its force is balanced by friction. We have to find the correct answer. Okay, we have to find the correct option. Clear? So this is the weight of the hanging part. Now friction between rope and table. Friction between rope and table. Friction between rope and table, how much can we write? It is equal to mu into normal reaction. What is mu? Mu is given as mu itself. Okay, so mu times normal reaction will be mass into G. Okay, mass into G, and that is equal to mu into or m dash into G. So the total mass by the total length into the remaining mass. The remaining length. What is the remaining length? L minus L1. Okay, so this is the normal reaction. Normal reaction is equal to mass divided by length into whatever the mass is being kept on the table. ടേബിളിലുള്ള മാസ് എത്രയാണ്? L1 ആണ് ഹാങ് ചെയ്ത് ഇറക്കുന്നുണ്ടെങ്കിൽ ബാക്കി എത്ര ഉണ്ടാകും? ബാക്കി L minus L1 ആയിരിക്കും എവിടെ ഉണ്ടാവുക? ടേബിളിൻ്റെ മേലെ ഉണ്ടാവുക. ക്ലിയർ അല്ലേ? സോ ഇൻറ്റു ജി. സോ നമുക്ക് എന്ത് കിട്ടി? മാക്സിമം വാല്യൂ ഓഫ് ഫ്രിക്ഷൻ അറിയാം, അതുപോലെ തന്നെ താഴേക്കുള്ള ഫോഴ്സ് അറിയാം. വി നോ ദി മാക്സിമം വാല്യൂ ഓഫ് ഫ്രിക്ഷൻ ആൻഡ് ദി ഡ്രൈവിംഗ് ഫോഴ്സ് ഓഫ് ദിസ് ഹോൾ സിസ്റ്റം. ക്ലിയർ? അങ്ങനെയാണെങ്കിൽ we can equate this weight can be equated with friction, which implies what is weight? mg by L1 is equal to mu m by L into L minus L1 into g. mg divided by L1 is equal to mu into m by L into L minus L1 into g. Okay, m by L, right? Yeah, m by L into g into L1. Yes, we can cancel the common terms. mg can be cancelled. Okay, by L can be cancelled. So L1 will be equal to mu times L minus L1. L1 will be equal to mu times L minus L1. Therefore mu is equal to, we have to find out, what do we have to find out? L1, we need to find out L1. Okay, L1 is what we need to find out. So L1 by mu is equal to L minus L1. Okay, therefore L is equal to L1 by mu plus L1. Okay, which implies L is equal to L1 into 1 by mu plus 1. L1 into 1 by mu plus 1. Therefore, L is equal to, therefore L1 is equal to, L divided by 1 by mu plus 1. L divided by 1 by mu plus 1. That is equal to mu L divided by 1 plus mu. Mu L divided by 1 plus mu. Which option is correct? Mu L divided by 1 plus mu, that is option C. Mu L divided by 1 plus mu, that is option C. Okay. So just let me know if you have understood the method. So the logic of doing this question, or the method of doing this question, is the same as the previous question. Okay, whatever that mass is hanging down the table, whatever the mass is hanging, that weight of that mass is the driving force here. Okay, and the mass, that is the remaining rope that is being kept on the table, friction on that rope is preventing this rope from falling down. Okay, how do we calculate the friction? Maximum value of friction is equal to mu times the normal reaction. That should be equal to weight of this falling part. Okay. The calculation, okay, let us go to the calculation again. So we started with this. Mass of the hanging part. Mass of the hanging part is, okay, Siras, mass of the hanging part is m by L into L1. Mass of the hanging part is m by L into L1 because L1 is hanging. So weight will be equal to m by L into L1 into G. Okay, and what about friction? Friction, we know the friction between rope and table is equal to mu into N. Friction between rope and table is equal to mu into N. Okay, how did you find out L1? L1, I just took it as L1. It is given in the question. Okay, L1 നമ്മൾ എന്തെടുത്തതാണ്? ഒരു arbitrary value ആയിട്ട് എടുത്തതാണ്. Okay, L1 എന്നുള്ളത് ഒരു general value ആയിട്ട് എടുത്തതാണ്. Understood? ആ L1 എന്നുള്ളത് ക്വസ്റ്റ്യനിൽ തന്നിട്ടുണ്ട്. നമുക്ക് എന്ത് ചെയ്താൽ മതി? അത് L1 എന്ന് മാത്രം എടുത്താൽ മതി. Okay. So L1 എന്നുള്ളത് നമ്മൾ എന്ത് ചെയ്തു? ജസ്റ്റ് ഒരു L1 മാത്രമായിട്ട് എടുത്തു. Therefore, mass of the hanging part will be m by L into L1. And weight എന്തായിരിക്കും അപ്പം? m by L into L1 into G. Okay, clear? So let me know if you are understanding. So okay, slow down. Okay, I will slow down. No problem with that. Friction between rope and table. Friction between rope and table എന്തായിരിക്കും? Mu into N. Okay, what is N? Normal reaction is equal to m by L into L minus L1, m by L into L minus L1. So this is the mass of the rope that is on the table. Okay, length is L minus L1. Length is L minus L1. Okay, m by L into L minus L1 into G ആണ് and the normal reaction. Clear? So ഇതിൻ്റെ weight ആണ് ഇവിടെ act ചെയ്യുന്നത്. That is equal to m by L into L minus L1 into G. M by L into L minus L1 into G. Understood? So we found out normal reaction. We got friction. So the frictional force should be equal to the weight of the rope that is hanging. Weight of the rope that is hanging. Understood? അത് equate ചെയ്യുന്നു, then we rearrange it. Okay. Clear? So previous question പോലെ തന്നെയാണ് ഇതും ചെയ്യുന്നത്. It is the same logic here. So this is the condition here. See, this part is hanging, right? This part is hanging and it has a weight here and there is friction here. There is friction acting at this point. So in order to prevent from any motion, in order to prevent the rope from sliding down, weight should be equal to friction. Weight should be equal to friction. Okay, weight should be equal to friction and അത് രണ്ടും കാൽക്കുലേറ്റ് ചെയ്ത് എന്ത് ചെയ്യാം? ഇക്വേറ്റ് ചെയ്താൽ നമുക്ക് എന്തിൻ്റെ റിലേഷൻ കിട്ടും? We will get the value of L1. L1 is what we needed to find out. That is how we find out L1. Mu L divided by 1 plus mu. Okay, clear? So all these two questions are have the same method of solving. So if you have understood the previous one, then you can easily understand this. Clear? Fine. Then let us go to the next one. Okay, many of you are asking the method again. Okay, I will try to explain it slowly once more. Okay, all of you please, those who did not understand it, please listen very carefully. So let me know if you have understood this logic. The friction on this part should be equal to the weight that is hanging down. friction or acting between the table and the part of the rope that is on the table should be equal to the weight of the rope that is hanging. Okay, so which means this system will be now in equilibrium. The rope will not be sliding down. Okay, the rope will not be sliding down. Clear? So mass of the hanging part. How do we find the mass of that hanging part? We can say the total mass is m and the total length is L. Okay, then the mass per unit length can be defined as m by L. Okay, mass per unit length can be defined as m by L, and when you multiply that mass per unit length into any part of that rope, you will get the mass of that required part. And how do you get the weight? You multiply it by G. Okay, clear? So all of you listen step by step very carefully. So our goal is to equate the friction and weight. Our goal is to equate the friction force and weight. So we got the weight here. We got the weight of the hanging part here. Now the next task is to find the value of frictional force. We know how to calculate the frictional force. The maximum value of frictional force is equal to mu n. The maximum value of frictional force is equal to mu into n. N is what? Normal reaction. Normal reaction of which part? The part that is kept on the table. Okay, understood? So n can be written as, just like how we wrote weight of the hanging part, we can write normal reaction using the same logic. How is it? M by L, that is mass per length, into L minus L1. L minus L1 is the length of the part that is on the table, multiplied by G will give you the normal reaction. There is no motion in the vertical direction. Therefore, weight of the part that is on the table will be equal to the normal reaction. Clear? That is given here. Okay. Therefore, friction is equal to mu into m dash into G. M dash is the mass of the rope that is on the table. So mu into m by L into L minus L1 into G. Okay, and like I told you, we can equate weight and friction. Clear? We can equate weight and friction. So mg by L into L1 is equal to mu into m by L into L minus L1 into G. Cancel m, cancel G, cancel L, and you are left with L1, which is equal to the remaining is mu into L minus L1. Understood? So I took this mu to the left side. L1 by mu will become L minus L1. Okay. Then what I did is I took L to the one side, L to the left side, and L1 by mu to the other side. Clear? L to one side and the other term L1 to the one side. Okay, I kept L on the one side. L is on the one side and this minus L1 went to the other side. Therefore it became L is equal to L1 by mu plus L1. And you can take L1 common from that, and that will give you 1 by mu plus 1. Therefore, from this we can write L1 is equal to L divided by 1 by mu plus 1. Okay, L divided by 1 by mu plus 1. Clear? That is L1 is equal to L divided by mu plus 1 by mu, and that is equal to mu L divided by mu plus 1. Okay, mu plus L. Clear? Okay. 1 plus mu actually. Okay. 1 plus mu. Clear? So that is it. I have explained it very slowly. I hope all of you have understood. Okay. So anyway, you have to practice it again. Such questions are very important. You can practice it again. Clear? So let us move on to the next question. So all of you read the question very carefully. Here also we are talking about 3 masses connected. Okay, we are talking about 3 masses connected with weightless strings in succession and are placed on a frictionless table. If the mass M3 is dragged with a force T, then the tension in the string is. between M2 and 3. Between M2 and M3. Between M2 and M3. So once again, the entire chapter, the entire laws of motion chapter, the only thing that you have to learn, the only formula or only concept that you have to learn is F is equal to ma. Okay. The only formula or only concept that you have to learn in this chapter is F is equal to ma. F is equal to ma vechittaan the entire chapter and solve. Okay. F equal to ma is the only equation or the only formula required to understand this entire chapter. Okay, please all of you quickly think about it. Please do this question. Which option is right? Okay, you can take 2 minutes. Do this question in under 2 minutes. Now you are now that you are learning this, I will give you 2 minutes. Okay, during the exam you should be solving this in under 30 seconds. Okay, so these are similar to the questions that we discussed during our class. Okay, these are very similar to the questions that we discussed in our class. So let me see who answers first. So what will happen to these three objects? So just let me know if they will move with the same acceleration as a single system, or will they have different accelerations. Let me know if they will move with the same acceleration or different accelerations. Will they be moving with the same acceleration or different acceleration? Option C. Okay, others, let me know if this bodies, if three objects are going to move with the same acceleration or different acceleration. They are going to go with same acceleration, right? They will be moving with same acceleration, right? Yes, very good, future doctors. They will be moving with same acceleration. And let us find out that same acceleration. How do we find the same acceleration? How do we find the common acceleration? Common acceleration is equal to total force by total mass. So total force divided by total mass. Total force by total mass. Okay, so now we want to find the value of tension between M2 and M3. Okay, so let me redraw the figure here. This is what we want to find out. So what is the logic here? See, this tension is actually pulling M1 and M2. The applied force is not reaching M2 and M1. Okay, we apply the external force direct M1 and M2. Understood? It is through tension that the force reaches to the bodies that are behind. Okay, so this tension that we have to find out. We kandupidikanda tension is responsible for taking these two bodies. The T dash is responsible for taking M1 and M2 together with the common acceleration. Okay, so here now we need to find out T dash. T dash, how much is T dash? T dash will be equal to M1 plus M2 into common acceleration. Okay, again what did we do? We applied F equal to ma here. So like I told you, in every problem in laws of motion, all you need to do is F equal to ma. There is no other equation. There is nothing else to worry about. Okay, F equal to ma is the only thing that you have to apply. So a common acceleration that we have already found out previously, and when you apply it here, you will get the T dash, tension between 2 and 3. And all of you are answering as the option C. Very good. All of you got the same answer. Very good. So M1 plus M2 into T divided by M1 plus M2 plus M3. Okay, so that was a very easy question. Clear? Option C. Okay, so using the same logic, please look at this question. Using the same logic, we look at this question. So in the previous question, we had different masses, right? Here it is a continuous mass. Here it is a rope. Okay, and what is the tension in the rope at a distance x from the force applied? What is the tension in the rope at a distance x from the end where the force is applied? Okay, we have to find the tension there. So what is the logic here? Again, it is the same logic as the previous question. It is the same logic as the previous question. That is, at any point, if you are calculating the tension, at any point in between a connected body, if you are calculating the tension, what you can do is find the common acceleration, and multiply that common acceleration with the mass behind that point. Okay. So that is what we did here. We multiplied the common acceleration with the mass behind the point. Okay, we can do the same here. Clear? So what is common acceleration? Common acceleration is equal to F divided by mass, force by total mass. Okay, so now when you look at this section closely, you have a tension here. This tension is actually pulling who? Who is this tension pulling? Tension is pulling the L minus X length of the rope. So all we need to do is now tension is equal to mass of the part that is behind the point. That is equal to mass divided by length. Total mass by per length. Mass per length into L minus X. Mass per length into L minus X will give you the mass behind that point multiplied by the common acceleration. And the answer is T into L minus X by L. Sorry, F into L minus X by L. F into L minus X by L. Yes, the answer is B. Right? Yes, many of you are answering it. I hope all of you got the answer. Clear? So in connected bodies, in any questions in connected bodies, if you are asked to find the tension in between, okay, find the common acceleration, multiply the common acceleration with the mass which is behind the point. So the logic is the tension at that point is pulling the remaining mass with the common acceleration. Okay, a point in the paragraph ബാക്കിയുള്ള mass ഉണ്ടല്ലോ, ബാക്കിയുള്ള mass അതിനെ ആ acceleration കൊണ്ട് pull ചെയ്യുന്ന force ആരാ? ആ ഇടയ്ക്കുള്ള ടെൻഷനാണ്. മനസ്സിലാവുന്നുണ്ടോ? Therefore നമുക്ക് എന്ത് കാണാൻ പറ്റും? ആ ടെൻഷൻ എങ്ങനെ കാണാൻ പറ്റും? കോമൺ ആക്സിലറേഷൻ എന്തുകൊണ്ട് മൾട്ടിപ്ലൈ ചെയ്താൽ മതി? ആ പിറകിലുള്ള മാസ് കൊണ്ട് മൾട്ടിപ്ലൈ ചെയ്താൽ മതി. Okay, അപ്പോൾ എല്ലാവർക്കും കിട്ടി മനസ്സിലായെന്ന് വിചാരിക്കുന്നു. I hope all of you understood that. Very simple question, please do it very fast. Clear? Okay, so let me know if you are able to understand this. Let me know if you are able to understand the questions, understand the explanation. Okay, a boy whose mass is 50 kilograms stands on a spring balance inside a lift. The lift starts to ascend with an acceleration of 2 meters per second square. The reading of the machine or the balance is equal to, okay, again waiting for you. Okay, try to do it as fast as possible. It is a D. One of you got the answer as D. Let's see, what about others? ബാക്കിയുള്ളവരൊന്നും ചെയ്യുന്നില്ലേ? കിട്ടിയ ആൻസർ യു ക്യാൻ സേ വാട്ട് എവർ ആൻസർ ദറ്റ് യു ഹാവ് ഗോട്ട്. ഓക്കെ, നിങ്ങൾക്ക് കിട്ടിയ ആൻസർ നിങ്ങൾക്ക് എന്ത് ചെയ്യാം? കമൻറ്റ് ചെയ്യാം. അത് തെറ്റിക്കോട്ടെ, നോ പ്രോബ്ലം. യു ക്യാൻ കമൻറ്റ് വാട്ട് എവർ ആൻസർ ദറ്റ് യു ഹാവ് ഗോട്ട്. Okay, 60 kilogram is the popular answer. Let's see what happens here. So this is a lift. Okay. 50 kilogram mass is inside the lift. Lift starts to ascend with an acceleration of 2 meter per second square. 2 meter per second square. Okay. So, this weighing machine, reading I have already told you, it is the normal reaction. Okay. It is the normal reaction that you are able to see as the reading in the weighing machine. Understood? So, let us see what is the normal reaction here. So, let us consider the free body diagram here. We have mg acting downwards. Normal reaction is acting perpendicularly upwards, and this body is moving with an acceleration of 2 meter per second square. This body is moving up with an acceleration of 2 meter per second square. Okay, clear? So the net motion resultant motion is upwards. Therefore, the force acting upwards minus the force acting downwards will give you the resultant force, right? Force acting upwards, normal reaction, minus force acting downwards, that is mg. This is equal to the resultant force. Okay, this is the resultant force. The resultant force is m into a. Understood? Because it is moving up with an acceleration of a. Therefore, n is equal to m into g plus a. Clear? So, n is equal to here m into g is 10 plus 2, that is equal to 5 into 12. Okay, what is mass? Mass is 50. So, 50 into 12 or 600 Newton. 600 Newton is normal reaction. Okay. So, the mass corresponding to this normal reaction will be shown in the weighing scale. The mass corresponding to this normal reaction will be shown in the reading. Therefore, the reading will be equal to n divided by mass, that is equal to 600 by 50 equal to 600 divided by what is the mass here? 600 divided by g. Okay, 600 divided by g, that is equal to 10, that is 60 kilogram. Okay, n divided by g, that is 60 kilogram. Option D. Understood? All of you understood that? So, these are a common type of questions. Okay, these are very common questions. A lift going upwards, lift going downwards, etc. So, you should practice enough number of questions with regarding this. Okay, so let's move to the next one. So, this question was asked in your test paper. Okay, and some of you were confused about it. Okay, so let me know before I explain this question. Please let me know if you are able to understand. Okay, so many of you got the correct answer here. Okay, very good. Aisha, Jubi, Angel, Lamia, Swadi. Okay, Christina, Aisha, Aparna, all of you got the correct answer. Very good. Okay. Are you able to understand? Class മനസ്സിലാവുന്നുണ്ടല്ലോ അല്ലേ? So we have a Ferris wheel here. Okay. എല്ലാവരും പോയിട്ടുണ്ടാവും എന്തെങ്കിലും എക്സിബിഷൻ ഒക്കെ നടക്കുമ്പോൾ ഫെറിസ് വീൽ എല്ലാവരും പോയിട്ടുണ്ടാവും. വെർട്ടിക്കൽ സർക്കുലർ മോഷനിൽ പോകുന്ന ഫെറിസ് വീൽ. Okay, so what is the question here? Consider the setup of a Ferris wheel in an amusement park. The wheel is turning in counterclockwise manner. So it is given here. The direction is given here. The wheel is turning in counterclockwise manner. Contrary to the illustration, not all seats are aligned horizontally. എല്ലാ സീറ്റും എന്തല്ല ഹൊറിസോണ്ടലി അല്ല അലൈൻ ചെയ്തിട്ടുള്ളത്. Okay, എല്ലാ സീറ്റും എന്തല്ല ഹൊറിസോണ്ടലി അല്ല അലൈൻ ചെയ്തിട്ടുള്ളത്. ഫൈൻ, വിച്ച് മീൻസ് they are not parallel to x-axis. Determine the orientation of the normal reaction. So the question is to find out the direction of normal reaction to the seat as it passes the point A. As it passes the point A. Okay, we need to find the direction of normal reaction. So the options are whether the normal reaction is parallel to x-axis, whether it is parallel to y-axis, or is it in the first and third quadrant, that is this direction. First and third quadrant. Okay, this direction. Clear? And second and fourth quadrant. fourth quadrant, that is this direction. These are the options. These are the options. So this is point A. Okay. Which option is correct? Which option is correct? So what are the normal to the seat? What are the forces acting on the seat? What are the normal reaction to the seat? Okay. So there will be a normal reaction like this. There will be a normal reaction like this. Also there will be a centripetal force. It is in a circular motion, and you know, in circular motion there must be a centripetal force. There must be a centripetal force. Okay, the centripetal force may be provided by friction, it may be provided by normal reaction, it may be provided by tension or gravitational force. Many examples are there, but there must be a centripetal force towards the center for any body to undergo circular motion. Clear? So therefore, apart from that, we will have a centripetal force also. We will have a centripetal force also. Two forces acting, and the resultant will be in this direction. Resultant will be in this direction. Okay, resultant will be in that direction. So this is second quadrant, and this is fourth quadrant. Okay, so the direction of the contact force is in the second and fourth quadrant. Understood? Option D, yes, many of you are answering option D. Very good. It is in second and fourth quadrant. Second and fourth quadrant. Answer is option D. Clear? So very simple question. Okay, so this question actually came in your test paper. നിങ്ങളുടെ എക്സാമിന് വന്ന ക്വസ്റ്റ്യൻ ആണ്, പക്ഷേ നിങ്ങൾക്ക് കിട്ടിയില്ലെന്ന് പറഞ്ഞു. കിട്ടാത്തതിൻ്റെ റീസൺ വേറെ ഒന്നുമില്ല, കാണുമ്പോൾ തന്നെ നിങ്ങൾക്കറിയാം. റൈറ്റ്, വെൻ യു ലുക്ക് അറ്റ് ദ പിക്ചർ, ദ മാസ് ഇസ് നോട്ട് ഗിവൺ. അണ്ടർസ്റ്റുഡ്? Mass is not given in the question, and that is the reason why you were not able to answer this question. So ഇത് ഡൗട്ടായിട്ട് കുട്ടികൾ സെൻഡ് ചെയ്തിരുന്നു. സോ നിങ്ങൾക്ക് ഇത് എക്സാമിൽ ചെയ്യാൻ പറ്റാത്തതിൻ്റെ കാരണം ഇതിൻ്റെ മാസ് തന്നിട്ടില്ല. ഓക്കെ, സോ നമുക്കൊരു കാര്യം ചെയ്യാം. മാസ് എന്താക്കിയെടുക്കാം? 2m ആൻഡ് m ആക്കിയിട്ട് എടുക്കാം. എന്നിട്ട് ചെയ്യാൻ പറ്റും. 2m ഉം m ഉം ആക്കിയിട്ട് ഇതിൻ്റെ മാസ് എടുക്കുക. ആക്സിലറേഷൻ, കോമൺ ആക്സിലറേഷൻ എന്തായിരിക്കും? ഓക്കെ, പ്ലീസ് ആൻസർ ദിസ് ഇൻ 30 seconds. Please answer this question in 30 seconds. We don't even have to spend any time on this question. It's actually very easy. Okay. Clear? What is the answer here? m minus m into g divided by 2m plus m, that is equal to g by 3. Right? G by 3. That's it. We don't have to spend any more time on that. Very simple question. Okay. So here is another question. So you had confusion with the friction, especially on the inclined plane, right? You had some confusions about friction in inclined plane. So here is a question based on that. So take your time, read the question, understand the question first. Understand the question first very carefully. A block is placed at the bottom of an inclined plane. A block is placed at the bottom of an inclined plane. So step number 1 is always draw the figure. Step number 1 is always draw the figure. Okay. Step number 1 is always draw the figure. Okay, so it is projected upwards with some initial speed. It slides up the plane and stops after time t1. After time t1. It begins to slide down back. It begins to slide back. It begins to slide back and reaches by time t2. The angle of inclination theta and coefficient of friction is mu. Then how can we compare the time? How can we compare the time? Okay, how can we compare the time here? T1, T2, which one is higher? Okay, so all of you who are attending this lecture, കാണുന്ന എല്ലാവരോടും എന്ത് ചെയ്യുക, ഡോപ്പ ചാനൽ സബ്സ്ക്രൈബ് ചെയ്യുക, യൂട്യൂബ് ചാനൽ സബ്സ്ക്രൈബ് ചെയ്യുക. ഈ ക്ലാസ്സസ് ഒക്കെ നിങ്ങൾക്ക് എന്ത് ചെയ്യാം, നിങ്ങളുടെ ഫ്രണ്ട്സിന് ഷെയർ ചെയ്ത് കൊടുക്കാം. ഓക്കെ, എല്ലാവർക്കും ഹെൽപ്ഫുൾ ആയിരിക്കും. ലോസ് ഓഫ് മോഷൻ്റെ കുറച്ച് ഇമ്പോർട്ടൻറ്റ് പ്രോബ്ലംസ് സോൾവ് ചെയ്യുന്നത് കാണുന്നത് എല്ലാവർക്കും ഹെൽപ്ഫുൾ ആയിരിക്കും. അപ്പോൾ നിങ്ങൾക്ക് അറിയാവുന്നവർക്കൊക്കെ എന്ത് ചെയ്യുക, ഷെയർ ചെയ്ത് കൊടുക്കുക, സബ്സ്ക്രൈബ് ചെയ്യാം. ഹൗ ഡു വി റിലേറ്റ് T1 and T2? How do we relate T1 and T2? Okay, so it is about direction of friction. We have to understand the direction of friction. So in the first figure, the object is trying to go upwards. In the first figure, the object is trying to go upwards. So what are the forces acting on it? What are the forces acting on it? mg, right? mg is acting downwards, and as a result, mg sin theta is acting here in this direction. Now, since the object is trying to move upwards, friction will be acting in the opposite direction. Okay, very carefully understand, friction always tries to oppose the relative motion. When the object is trying to go upwards, the friction will oppose that. So here the direction of friction is opposite to the motion. Okay, and what about in the other case? In the second case, what about the second case? Second case, in the second case, see mg sin theta. mg sin theta is acting downwards. mg sin theta is actually responsible for bringing this block bringing this block downwards. And friction will again try to oppose that motion. Friction will again try to oppose that relative motion, and we can say the direction of friction will be this in this case. Okay. Clear? Understood? Therefore, displacement is same. Okay, displacement is same. Displacement is same for both case. Displacement is same for both case, and acceleration for the first one, acceleration is going to be minus f plus mg sin theta divided by mass. Okay, so it is going to be a retardation. The speed will decrease and it will reach zero. Speed will decrease and it will reach zero because both the forces are now acting in the opposite direction. Both the forces are now acting in the opposite direction. Case number 1. And what about case number 2? Case number 2, the acceleration is equal to mg sin theta minus friction divided by mass of the object. Okay, mg sin theta minus friction divided by mass of the object. Okay, so in the second case, mg sin theta is supporting this object and friction is opposing it. But in the first case, both mg sin theta and friction are opposing the object. There is no one to support the object. Okay, clear? Understood? Okay, got the point? So which time is actually higher? Which time will be higher? Which time is going to be higher? So some of you, many of you have answered B. Option B, you have answered option B. T1 is greater than T2. T1 as greater than T2. Many of you answered T1 as greater than T2. Okay, so which will happen? T1 is greater than T2 or T2 is greater than T1? Okay, please, the remaining students also, everyone please try to answer. Everyone please to try to give your opinions. Try to give your opinions for this question. Okay, it may be wrong, no problem with that, just answer it. So I'm waiting for more of you to participate. Right, so T is equal to V minus U divided by A. Right, V is equal to U plus AT. T is equal to, time is equal to V minus U divided by A. Time is equal to V minus U divided by A. And time, when you calculate time, this change in velocity here is same. Change in velocity is same. Okay, but acceleration is different. So which time will be smaller? Which time will be smaller? See, in the denominator you have higher value in A1. Okay, in the denominator you have higher value in A1. In the denominator acceleration is what is different here. Okay, which one has higher magnitude of acceleration? Which one has higher magnitude of acceleration? So T1 will be equal to divided by A1, and T2 will be equal to V minus U divided by A2. So now look at it and tell me which time is higher. Numerator is the same, denominator is different. Numerator is same, denominator is different. Which denominator is higher? This one or this one? Which acceleration is higher? Which acceleration has higher magnitude? Which acceleration has higher magnitude, A1 or A2? Which acceleration has higher magnitude? Which acceleration has higher magnitude? Which acceleration has higher magnitude? Okay. Magnitude of A1 is greater than magnitude of A2. Magnitude of A1 is greater than magnitude of A2. Yes, very good. Magnitude of A1 is greater than magnitude of A2. So denominator is higher for which one? Numerator is same. Numerator is same because initial velocity, final velocity is 0. 0 and u, that values are same. 0 and u, that values are same. Acceleration magnitude is different. A1 is higher, and therefore we can say, since the denominator of T1 is higher, we can say T1 is less than T2. Understood? Just let me know if you have understood. Okay. Magnitude of A1 is higher than A2. So you look at the fraction T1 and T2. Denominator A1 is higher compared to A2. Numerator is the same. Therefore, T1 will be less than T2. Okay? Just let me know if everyone has understood. So in practical sense, when you think about it, when the object is moving upwards, both the forces are pulling it backwards. So it will stop soon, it will stop earlier. Okay, when it is coming down, only one force is pulling it backwards, the other force is supporting it. Okay, Okay, in the first case, what happens is both are pulling it down and it will stop sooner than the other one. Okay, T1 will be less than T2. Clear? Okay, let me know if all of you have understood that. Okay, this is the approach. Okay, just reach the final answer. Don't go and mark your answer before you have 100%, before you are 100% confident about it. Okay, because it is always very easy to make mistakes. Clear? So let us move to the next one. A block rests on a rough inclined plane. A block rests on a rough inclined plane. Okay. On a rough inclined plane, theta 30 degree, with the horizontal coefficient of static friction between the block and the plane is 0.8. If the frictional force on the block is 10 Newton, mass of the block is. This, I think, it is an easy question. I think you can calculate this, right? Okay, so the only solution or the only shortcut to be good at problem solving is by doing as many problems as possible. Okay, there is no other shortcut. To solve questions fast. It is only by practice. Practice is the only solution. Okay. So when you see this shortcut to success, so what does the shortcut actually mean? It is actually more and more practice. Okay. So here it is it C? Okay, so when you look at the free body diagram, we have friction in this direction, we have friction like this, mg sine theta. Okay, mg sine theta, friction. So the block is resting on a plane making an angle 30 degree. Coefficient of friction is given. If the frictional force acting on the block is 10 Newton, frictional force acting on the block is 10 Newton, then what is the weight? Okay. So mg will be here. Mg cos theta and we have normal reaction here. Okay, we have normal reaction here. Clear? Got the idea? Okay, so it is 30 degree. It is 30 degree. We know that n is equal to mg cos theta. Here n will be equal to mg cos theta and frictional force will be equal to mu times normal reaction. Frictional force will be equal to mu times normal reaction. That is equal to 0.8 into mg cos theta. 0.8 into mg cos theta. Okay, that is 10 Newton. Frictional force is given in the question as 10 Newton. So 10 Newton is equal to 0.8 into mass we should find out, right? Mass we should find out. So mg into cos 30. mg into cos 30. Okay. Question Malayalam. Okay. So this question is an inclined plane. Okay. So Nivedya, listen very carefully. We have an inclined plane. An inclined plane is the matter object. ആ ഇൻക്ലൈൻഡ് പ്ലെയിന് ഹൊറിസോണ്ടലുമായിട്ട് ഉണ്ടാക്കുന്ന ആംഗിൾ 30 ഡിഗ്രിയാണ്. ഹൊറിസോണ്ടലുമായിട്ട് ഉണ്ടാക്കുന്ന ആംഗിൾ 30 ഡിഗ്രിയാണ്. പിന്നെ കോഎഫിഷ്യൻ്റ് ഓഫ് സ്റ്റാറ്റിക് ഫ്രിക്ഷൻ ബിറ്റ്വീൻ ബ്ലോക്കും പ്ലെയിനും തമ്മിലുള്ള കോഎഫിഷ്യൻ്റ് ഓഫ് സ്റ്റാറ്റിക് ഫ്രിക്ഷൻ 0.8 ആണ്. ഓക്കെ. ദ ഫ്രിക്ഷണൽ ഫോഴ്സ് ഓൺ ദ ബ്ലോക്ക് ഈസ് 10 ന്യൂട്ടൺ. ഫ്രിക്ഷണൽ ഫോഴ്സ് ഓൺ ദ ബ്ലോക്ക് എന്ന് പറയുന്നത് 10 ന്യൂട്ടൺ ആണ് തന്നിട്ടുണ്ട്. വി ഹാവ് ടു ഫൈൻഡ് ദ മാസ് ഓഫ് ദ ബ്ലോക്ക്. ഓക്കെ, മാസ് ഓഫ് ദ ബ്ലോക്ക് ആണ് കണ്ടുപിടിക്കേണ്ടത്. അണ്ടർസ്റ്റുഡ്? So how do we find out? ആദ്യം തന്നെ എന്ത് ചെയ്യുക? ഫ്രീ ബോഡി ഡയഗ്രാം വരയ്ക്കുക. എം ജി ഡയറക്റ്റ്ലി താഴേക്ക് വരും. അതിൻ്റെ രണ്ട് കോമ്പണൻസ്, ഒന്ന് എം ജി കോസ് തീറ്റ, മറ്റത് എം ജി സൈൻ തീറ്റ. ഇൻക്ലൈൻഡ് പ്ലെയിൻ ഡൗൺ ആയിട്ട് വരും. ഫ്രിക്ഷൻ്റെ ഡയറക്ഷൻ ഓപ്പോസിറ്റ് ആണ്. ഇറ്റ് ഈസ് ഓപ്പോസിറ്റ് ടു ദി ഇറ്റ് ഈസ് അപ്വേർഡ്സ് വിത്ത് റെസ്പെക്ട് ടു ദി ഇൻക്ലൈൻഡ് പ്ലെയിൻ ആൻഡ് നോർമൽ റിയാക്ഷൻ ഇസ് പെർപെൻഡിക്കുലർലി അപ്വേർഡ്സ് ആയിട്ടാണ് എന്ത് നോർമൽ റിയാക്ഷൻ ഉണ്ടാവുക. നോർമൽ റിയാക്ഷൻ എം ജി കോസ് തീറ്റയാണ്. ബിക്കോസ് ആ ഡയറക്ഷനിൽ എന്തില്ല, മോഷൻ ഒന്നുമില്ല. Therefore, frictional force is equal to mu into n. Frictional force is equal to mu times mu multiplied by normal reaction. Frictional force is given as 10 Newton. 10 Newton ആണ് ക്വസ്റ്റ്യനിൽ തന്നിട്ടുണ്ട്. 0.8 ആണ് mu. n എന്ന് പറയുന്നത് mg cos 30 ആണ്. So 0.8 into m into 10 into cos 30. Cos 30 is how much? Root 3 by 2. Cos 30 is root 3 by 2. Cancel 10. 10 you can cancel and m is equal to 2 divided by 0.8. 2 divided by 0.8 into 1 by root 3. Okay. 0.8 denominator like vannu. 2 left side la numerator like poi. Root 3 again denominator like vannu. Clear? So what are the options here? We have 1.6, 4, 2 and 2.5. Okay. Clear? So what is the answer here? 2 divided by 0.8 into root 3 is equal to m. So to simplify this, we can multiply both sides with root 3. We can multiply numerator and denominator with root 3. Okay, so 2 root 3 divided by 0.8 into 3 എന്ന് വരും. Multiplied both by root 3. Numerator and denominator they are root 3 വെച്ച് multiply equal to m. So this is equal to root 3 is equal to 1.73. Therefore, root 3 by 3 is equal to how much? 1.73 divided by 3. 1.73 divided by 3 എന്ന് പറയുന്നത് 0.58. Approximately 0.58. So 2 times 0.8 and 2 by 0.8 എന്നുള്ളത് എത്ര വരും? 2 by 0.8 എന്നുള്ളത് 2.5. Okay. Clear? Therefore, the answer is 2.5 into 0.58. Okay, 2.5 into 0.58. Approximately എത്ര വരും? 1.6, approximately 1.6. Right, 2.5 into 0.5 എന്ന് പറയുന്നത് 1.25 ആണ്, ഹാഫ് ഓഫ് 2.5 ആണ്. അഗെയിൻ a little more than that, that is 1.6. Okay, option A. How many of you got the answer as option A? ആർക്കും കിട്ടിയില്ലേ? ഓക്കെ, അണ്ടർസ്റ്റുഡ്. എല്ലാവർക്കും മനസ്സിലായോ? ആൻസർ 1.6 എങ്ങനെയാണ് വന്നതെന്നുള്ളത്. അപ്പോൾ സോ അപ്രോക്സിമേറ്റ്ലി ആൻസർ ഇസ് ഈക്വൽ ടു 1.6 കിലോഗ്രാം. ആൻസർ ഇസ് ഈക്വൽ ടു 1.6 കിലോഗ്രാം. Understood? So just let me know. Everyone, please let me know through your messages if you have understood that. Okay. Okay, option A is the right answer. Students, okay, option A is the right answer. Okay, let's go to the next one. Let us go to the next question. System is pushed by a force F. So all of you read the question. I will explain in Malayalam. So, 3 objects ഉണ്ട്, A, B, C. Okay, ഒരു കോമൺ ഫോഴ്സ് ഒരു സൈഡിൽ നിന്ന് കൊടുക്കുന്നുണ്ട്. 3 objects A, B, C ഒരു കോമൺ ഫോഴ്സ് കൊടുക്കുന്നുണ്ട്. Friction coefficient between B and C is mu. Friction coefficient between B and C is mu. Okay. All surfaces are smooth except B and C കിടക്ക് മാത്രമേ എന്തുള്ളൂ? ഫ്രിക്ഷൻ ഉള്ളൂ. അവിടെ മാത്രമേ എന്തുള്ളൂ? ഫ്രിക്ഷൻ ഉള്ളൂ. ബാക്കിയെല്ലാം സ്മൂത്താണ്. Minimum value of force to prevent block B from downward slipping. Minimum value of force to prevent block B from downward slipping. So, ഇങ്ങനത്തെ ക്വസ്റ്റ്യൻസിൽ, in questions like this where you are asked to find the minimum value of force to stop moving or maximum value of force to prevent any motion. Understood? അതായത് മോഷൻ നടക്കരുത്, 2 ഒബ്ജക്ട്സ് തമ്മിൽ മോഷൻ ഉണ്ടാവാൻ പാടില്ല, അതിന് വേണ്ട മാക്സിമം ഫോഴ്സ് മിനിമം ഫോഴ്സ് എന്നൊക്കെ പറഞ്ഞ ക്വസ്റ്റ്യൻ വരും. ഇൻക്ലൈൻഡ് പ്ലെയിനിൽ വരാറുണ്ട്, സ്ട്രെയിറ്റ് ഹൊറിസോണ്ടലിൽ വരാറുണ്ട്, ഇങ്ങനെ കണക്റ്റഡ് ബോഡീസിനും വരാറുണ്ട്. അണ്ടർസ്റ്റുഡ്? സോ ആ കേസിലൊക്കെ എന്താ സംഭവിക്കുന്നത്? നമ്മൾ കൊടുക്കുന്ന ഫോഴ്സ് ഒന്നെങ്കിൽ അത് ഫോഴ്സിനെ ഡയറക്റ്റായിട്ട് അല്ലെങ്കിൽ ആ ഫോഴ്സിൻ്റെ ഒരു കോമ്പോണൻറ്റിനെ ആരെ ഒപ്പോസ് ചെയ്യുന്നുണ്ടാകും? ഫ്രിക്ഷൻ ഒപ്പോസ് ചെയ്യുന്നുണ്ടാകും. മനസ്സിലാവുന്നുണ്ടോ? ഫ്രിക്ഷൻ ഒപ്പോസ് ചെയ്യുന്നത് കൊണ്ടാണ് ഈ റിലേറ്റീവ് മോഷൻ ഇവിടെ പോസിബിൾ അല്ലാത്തത്. അത് ഇൻക്ലൈൻഡ് പ്ലെയിനിലെ കേസിലാണെന്നുണ്ടെങ്കിലും തിയറി അത് തന്നെയാണ്, ഹൊറിസോണ്ടൽ കേസിലും അത് തന്നെയാണ്, കണക്റ്റഡ് ബോഡീസ് ആണെങ്കിലും സെയിം തിയറി തന്നെയാണ്. ഓക്കെ, സോ ഇങ്ങനത്തെ ക്വസ്റ്റ്യൻസിലൊക്കെ ഈ മാക്സിമം ഫോഴ്സും മിനിമം ഫോഴ്സൊക്കെ കണ്ടുപിടിക്കാൻ പറ്റുന്ന ക്വസ്റ്റ്യൻസിലൊക്കെ നമ്മൾ ചെയ്യേണ്ടത് എന്താണ്? ഫ്രിക്ഷനുമായിട്ട് റിലേറ്റ് ചെയ്യുക. ഓക്കെ, ആ സർഫസിൽ, ഈ തന്നിട്ടുള്ള സർഫസിലെ മാക്സിമം ഫ്രിക്ഷൻ എത്രയാണെന്ന് നോക്കുക. ഫൈൻഡ് ഔട്ട് ദി മാക്സിമം ഫ്രിക്ഷൻ ഇൻ ദാറ്റ് പെർട്ടിക്കുലർ സർഫസ്. ഫൈൻഡ് ഔട്ട് ദി മാക്സിമം ഫ്രിക്ഷൻ ബിറ്റ്വീൻ ദാറ്റ് പെർട്ടിക്കുലർ ബോഡീസ്. ഓക്കെ, ആൻഡ് റിലേറ്റ് ദം വിത്ത് ദ ഫോഴ്സ് അപ്ലൈഡ്. അതിനെ എന്ത് ചെയ്യുക? നമ്മൾ അപ്ലൈ ചെയ്ത ഫോഴ്സുമായിട്ട് റിലേറ്റ് ചെയ്യാം. മനസ്സിലാവുന്നുണ്ടാവും? ഓക്കെ, ക്ലിയർ? അങ്ങനെയാണെങ്കിൽ ഇതൊന്ന് ചെയ്ത് നോക്കുക എല്ലാവരും. ഓക്കെ, വേറെ എവിടെയും ഫ്രിക്ഷൻ ഇല്ലാത്ത സ്ഥിതിക്ക് ദിസ് എൻറ്റയർ ഒബ്ജക്റ്റ് വിൽ ഇറ്റ് ബി മൂവിങ് വിത്ത് എ കോമൺ ആക്സിലറേഷൻ ഓർ നോട്ട്? Common acceleration or not? Will it be moving with a common acceleration or not? Will it be moving with a common acceleration or not? See, there is no friction on the ground, there is no friction between A and B. You are just pushing from one side. എയുടെ ഒരു സൈഡിൽ നിന്നാണ് എന്ത് ചെയ്യുന്നത്? പുഷ് ചെയ്യുന്നത്. ബിക്കും സിക്കും ഇടയ്ക്ക് എന്തില്ല? ഫ്രിക്ഷൻ ഇല്ല. സോറി, ബിക്കും സിക്കും ഇടയ്ക്ക് മാത്രമാണ് ഫ്രിക്ഷൻ ഉള്ളത്. ബിറ്റ്വീൻ എ ആൻഡ് ബി ദർ ഇസ് നോ ഫ്രിക്ഷൻ. ഓക്കെ, ഐ ഹോപ്പ് ഓൾ ഓഫ് യു ആർ ഡൂയിങ്. Okay, so will they be moving with a common acceleration? Yes, yeah, they will be moving with a common acceleration. They will be moving with a common acceleration, a common. That common acceleration is equal to F divided by 2m plus m plus 2m. Total force by total mass. That is common acceleration. So this is equal to F divided by 5m. So that is equal to F divided by 5m. Common acceleration. Okay. So now let us consider the two objects. Okay. So B has a tendency to move down. B has a tendency to move down because of gravity. B has a tendency to move down because of gravity. And the only force that will help to prevent that downward motion is friction, right? Friction മാത്രമേ എന്ത് ചെയ്യാൻ പറ്റുള്ളൂ, ഈ ബി താഴേക്ക് പോകുന്നതിൽ നിന്ന് പിടിച്ചു വെക്കാൻ പറ്റുള്ളൂ. Therefore ഫ്രിക്ഷൻ്റെ ഡയറക്ഷൻ എങ്ങനെയായിരിക്കണം? ഫ്രിക്ഷൻ്റെ ഡയറക്ഷൻ നേരെ മേലേക്കായിരിക്കണം. ഓക്കെ, ഫ്രിക്ഷൻ്റെ ഡയറക്ഷൻ നേരെ മുകളിലേക്കായിരിക്കണം. ഓക്കെ, ക്ലിയർ അല്ലേ? And we also know that what is the basic definition of friction? What is the basic definition of friction? Friction is equal to mu times normal reaction. Friction is equal to mu times normal reaction. Okay, what is normal reaction here? Normal reaction എങ്ങനെ കണ്ടുപിടിക്കും? When we keep an object on the table, നമ്മൾ ടേബിളിൻ്റെ മേലെ ഒരു ഒബ്ജക്റ്റ് വെക്കുന്ന സമയത്ത് ആ ടേബിളിൻ്റെ വെയിറ്റ് ഒബ്ജക്റ്റിൻ്റെ മേലേക്ക് ആക്ട് ചെയ്യും. അതിൻ്റെ ഭാഗമായിട്ട് ആസ് എ റീസൺ എ നോർമൽ റിയാക്ഷൻ വിൽ ബി opposite to that. Okay, normal reaction is a contact force. It is not the action reaction pair of mg. Okay, ക്ലാസ്സിൽ നമ്മൾ വ്യക്തമായിട്ട് എക്സ്പ്ലെയിൻ ചെയ്തിരുന്നത് എവറി ആക്ഷൻ ഹാസ് എൻ ഈക്വൽ ആൻഡ് ഓപ്പോസിറ്റ് റിയാക്ഷൻ, ന്യൂട്ടൺസ് തേർഡ് ലോ. ആ ആക്ഷൻ റിയാക്ഷൻ പെയർ അല്ല എന്ത്, എം ജിയും നോർമൽ റിയാക്ഷനും. ആ കൺഫ്യൂഷൻ എല്ലാവരും ഇപ്പോൾ തന്നെ തീർക്കണം. ക്ലാസ്സിൽ വെൽ ആയിട്ട് എക്സ്പ്ലെയിൻ ചെയ്തതാണ്. വി ഹാവ് വെരി ക്ലിയർലി എക്സ്പ്ലെയിൻഡ് നോർമൽ റിയാക്ഷൻ ആൻഡ് എം ജി ഇസ് നോട്ട് ആക്ഷൻ റിയാക്ഷൻ പെയർസ്. Okay, the reaction of mg is on earth. So mg is the force exerted by earth on the object. Similarly, the object will exert a force on earth from its center, and that is very negligible. That is the action reaction pair there. Okay, clear? Normal reaction is another type of contact force. Normal reaction is another type of contact force. So F is equal to mu n. F is equal to mu n. So here the normal reaction will be due to, there will be a force between them, force between B and C, right? So here we have our A, and you are doing what? You are pushing A. You are pushing A with a force F. Okay, and therefore there will be A will push B and B will push A back. A will push B and B will push A back. Similarly, B will push C and B will push C and C will push C back. Okay, just like tension. If there was a string in between these blocks, ടെൻഷൻ അവിടെ കാണാൻ പറ്റുമായിരിക്കില്ലേ? ടെൻഷൻ എയിൽ നിന്നൊരു ടെൻഷൻ ഉണ്ടാകും, അതേപോലെ തന്നെ ബിയിൽ നിന്നൊരു ടെൻഷൻ ഉണ്ടാകും. ആ ടെൻഷന് പകരം ഇവിടെ എന്താണ്? കോണ്ടാക്ട് ഫോഴ്സ് ആണ്. ആ ടെൻഷന് പകരം എ എന്ത് ചെയ്യും? ബീനെ പുഷ് ചെയ്യും. അപ്പോൾ നിങ്ങൾ അസംബ്ലി ലൈനിൽ പിറകിലിരിക്കുന്ന ആൾ അയാളുടെ തൊട്ട് മുന്നിലുള്ള ആളെ ചവിട്ടി കഴിഞ്ഞാൽ ആ ആളെന്ത് ചെയ്യും? തൊട്ട് മുന്നിലുള്ള ആളെ പോയിട്ട് ചവിട്ടും, അല്ലേ? അസംബ്ലി ലൈനിൽ എല്ലാവരും നിൽക്കുന്ന സമയത്ത് ഏറ്റവും ബാക്കിലുള്ള ആൾ തൊട്ട് മുന്നിലുള്ള ആൾക്ക് ഒരു ചവിട്ട് കൊടുത്തു കഴിഞ്ഞാൽ അയാൾ എന്ത് ചെയ്യും? തൊട്ട് മുന്നിലുള്ള ആൾ പോയി അടിക്കും. അങ്ങനെ ആ ഫോഴ്സ് എന്ത് ചെയ്യും? കോൺടാക്ട് ചെയ്ത് അങ്ങോട്ടും ഇങ്ങോട്ടും പോലെ. അങ്ങനെ ആ വീണവൻ എന്ത് ചെയ്യും? എഴുന്നേറ്റ് നിന്നിട്ട് തിരിച്ച് മറ്റോണിട്ടൊന്ന് കൊടുക്കും, അല്ലേ? അപ്പോൾ എന്തായി? ഒരു ഫോഴ്സ് അങ്ങോട്ടും കൊടുത്തു, ഒരു ഫോഴ്സ് ഇങ്ങോട്ടും കിട്ടി. സിമിലർലി എ എന്ത് ചെയ്യും? ഈ പിറകുന്ന് കിട്ടിയ എഫ് കാരണം ബീനെ പുഷ് ചെയ്യും, ബി എന്ത് ചെയ്യും? തിരിച്ചിങ്ങോട്ടും പുഷ് ചെയ്യും. എവറി ആക്ഷൻ ഹാസ് എൻ ഈക്വൽ ആൻഡ് ഓപ്പോസിറ്റ് റിയാക്ഷൻ. മനസ്സിലാവുന്നില്ലേ? ഓക്കെ, സോ വെൻ വി ലുക്ക് അറ്റ് എസ് ഫ്രീ ബോഡി ഡയഗ്രാം, യു ഹാവ് എഫ് ഹിയർ. Okay, when you look at the free body diagram of A, you have F acting here and the contact force of B and the contact force of B. And what is the common acceleration? Common acceleration is F by 5m. Okay, so the net force on A will be F minus FB. F minus FB divided by m is equal to F by 5m. Understood? So the net force acting on A is actually capital F minus FB divided by the mass will give you the common acceleration. All are moving with the common acceleration. Cancel M, therefore F minus FB is equal to F, which means what does it mean? F by 5. Okay, so therefore FB is equal to F minus F by 5, that is equal to 4F by 5. So FB is equal to 4F by 5. Clear ആവുന്നില്ല എല്ലാവർക്കും? FB is equal to 4F by 5. So ഇതാ സെയിം മെത്തേഡ് തന്നെ, സെയിം പ്രൊസീജിയർ തന്നെ, 1 by 1 ആയിട്ട് ഇങ്ങനെ ചെയ്യാം. ഓരോരോ ബോഡിയുടെ എന്തെടുക്കുക, ഫ്രീ ബോഡി ഡയഗ്രാം എടുക്കുക. ഇനി നമുക്ക് ബിയുടെ എടുക്കാം. ഇപ്പോൾ നമുക്ക് എന്ത് മനസ്സിലായി? ബി എനെ തള്ളുന്ന ഫോഴ്സ്, the force exerted by B on A is 4F by 5. Therefore, അതേ ഫോഴ്സ് എങ്ങോട്ടും ഉണ്ടാകും? ഇങ്ങോട്ടും ഉണ്ടാകും. 4F by 5 അങ്ങോട്ടും ഉണ്ടാകും. ക്ലിയർ അല്ലേ? 4F by 5 എന്തുണ്ടാകും? ബീൻ്റെ മേലേക്ക് ഉണ്ടാകും. ശരിയല്ലേ? ഇവിടെ പറഞ്ഞ പോലെ ആക്ഷൻ റിയാക്ഷൻ പെയർ ആണത്. ക്ലിയർ അല്ലേ? ഇനി ബീൻ്റെ മേലെ വേറെ എന്തൊക്കെ ഫോഴ്സ് ഉള്ളത്? ബീൻ്റെ മേലെ സി തരുന്ന ഫോഴ്സ് ഉണ്ട്. കറക്റ്റ് അല്ലേ? സി തരുന്ന ഫോഴ്സ് ഉണ്ട്. അതേപോലെ തന്നെ എന്ത് ചെയ്യുന്നുണ്ട്? സിയുടെ മേലേക്ക് ഒരു ഫോഴ്സും അപ്ലൈ ചെയ്യുന്നുണ്ട്. അപ്പോൾ ബിയുടെ മേലെയുള്ള ഫോഴ്സ് എന്ന് പറയുന്നത്, ബി എന്തൊക്കെ ചെയ്യുന്നുണ്ട്? ഓക്കെ, ക്ലിയർ? ഇതാണ് ബിയുമായി റിലേറ്റ് ചെയ്തിട്ടുള്ള ഫോഴ്സസ്. ബിയുടെ ഫ്രീ ബോഡി ഡയഗ്രാം വരയ്ക്കുമ്പോൾ എ പുഷ് ചെയ്യുന്നുണ്ട്, അതേപോലെ തന്നെ ബി എന്ത് ചെയ്യുന്നുണ്ട്? സീനെ പുഷ് ചെയ്യുന്നുണ്ട്. ആസ് എ റിസൾട്ട് സി ഈസ് പുഷിങ് ബി ബാക്ക്. സോ നമുക്ക് ഈ ഫോഴ്സിനെ എന്ത് വിളിക്കാം? എഫ് ഡ്യൂ ടു സി എന്ന് വിളിക്കാം. ഇനി അതാണ് നമ്മൾ കണ്ടുപിടിക്കാൻ പോകുന്നത്. അവിടെ നമ്മൾ എന്ത് ഐഡിയ യൂസ് ചെയ്യുക? കോമൺ ആക്സലറേഷൻ ടെക്നിക്കാണ് യൂസ് ചെയ്യുക. ഓക്കെ, സോ വാട്ട് ഈസ് ദ നെറ്റ് ഫോഴ്സ് ആക്ടിങ് ഓൺ ബി? സോ അതിന് നമുക്ക് ഇതിൻ്റെ ആവശ്യമില്ല, കാരണം ഓൺ ബി ആണ് നമ്മൾ നോക്കുന്നത്. വാട്ട് ഈസ് ദ നെറ്റ് ഫോഴ്സ് ആക്ടിങ് ഓൺ ബി? നെറ്റ് ഫോഴ്സ് ആക്ടിങ് ഓൺ ബി ഇസ് 4F by 5 മൈനസ് FC is the net force acting on B ഡിവൈഡഡ് ബൈ അതിൻ്റെ മാസ് ചെയ്ത് കഴിഞ്ഞാൽ. ഓക്കെ, ഡിവൈഡഡ് ബൈ അതിൻ്റെ മാസ് ചെയ്ത് കഴിഞ്ഞാൽ. Okay, there is a small correction here because it should have been 2m here, right? We should have taken the mass of A here. Understood? We should have taken the mass of A here, that is 2m. So in here the denominator will be 2m. Clear? So there will be a very small adjustment here. So we can say this is F by 2. Here we can write FB by 2. Okay. So F by 2 minus F by 5 is equal to FB by 2. And when you solve that fraction, you will get 5F minus 2F divided by 10 is equal to FB by 2. Clear? And cancel 2 and you have a 5 here. And this will be equal to 5F minus 2F is equal to 3F divided by 5. Okay, a very small correction. 3F divided by 5 ആണ് FB. ക്ലിയർ? ആ സെയിം ലോജിക് നമുക്ക് ഇവിടെ യൂസ് ചെയ്യാം. നെറ്റ് ഫോഴ്സ് ആക്ടിങ് ഓൺ ബി എന്ന് പറയുന്നത് എന്തായിരിക്കും? അപ്പം നെറ്റ് ഫോഴ്സ് ആക്ടിങ് ഓൺ ബി എന്ന് പറയുന്നത് 3F by 5. 3F divided by 5 minus 3F divided by 5 minus 3F divided by 5 minus, okay, FC divided by m. So this is equal to the common acceleration. What is the common acceleration? F divided by 5m. Common acceleration is equal to F divided by 5m. You can cancel the m. 3F by 5 minus FC is equal to capital F. Okay, 3F by 5 minus FC is equal to capital F. Clear? Therefore FC is equal to 3F by 5 minus F. FC is equal to 3F by 5 minus F. Okay, therefore FC is equal to how much is FC? Minus 2F divided by 5. Okay, FC is equal to minus 2F divided by 5. അതാണ് എന്തിൻ്റെ ഡയറക്ഷൻ കിട്ടിയത്? ഫോഴ്സിൻ്റെ ഡയറക്ഷൻ കിട്ടി. ക്ലിയർ അല്ലേ? ഫോഴ്സിൻ്റെ മാഗ്നിറ്റ്യൂഡ് കിട്ടി. ഫോഴ്സ് ബിറ്റ്വീൻ ബി ആൻഡ് സി. ഫോഴ്സ് ബിറ്റ്വീൻ ബി ആൻഡ് സി കിട്ടി. ഓക്കെ, ക്ലിയർ? സോ ജസ്റ്റ് ലെറ്റ് മീ നോ ഇഫ് യു ഹാവ് അണ്ടർസ്റ്റുഡ് സോ ഫാർ. All of you, please let me know if you have understood so far. First, we considered only A. We draw the free body diagram of A and find out the contact force between A and B. ആ കോണ്ടാക്ട് ഫോഴ്സ് എത്രയാണ് കിട്ടിയത്? 3F by 5 എന്ന് കിട്ടി. ഇനി അത് യൂസ് ചെയ്തിട്ട് നമ്മൾ എന്ത് ചെയ്യും? ബിയുടെ ഫ്രീ ബോഡി ഡയഗ്രാം വരയ്ക്കും. ബിയുടെ ഫ്രീ ബോഡി ഡയഗ്രാം വരയ്ക്കും. ഓക്കെ, ബിയുടെ ഫ്രീ ബോഡി ഡയഗ്രത്തിൽ ഹൊറിസോണ്ടൽ ഡയറക്ഷനിൽ രണ്ട് ഫോഴ്സസ് ആണുള്ളത്. ഒന്ന് എ ബിയുടെ മേലെ എക്സേർട്ട് ചെയ്യുന്ന ഫോഴ്സ്, രണ്ടാമത്തത് സി ബിയുടെ മേലെ എക്സേർട്ട് ചെയ്യുന്ന ഫോഴ്സ്, രണ്ടാമത്തത് സി ബിയുടെ മേലെ എക്സേർട്ട് ചെയ്യുന്ന ഫോഴ്സ്. ക്ലിയർ? ഓക്കെ. സോ അങ്ങനെ ചെയ്യുന്ന സമയത്ത് ഇറ്റ് ഷുഡ് ബി 5 ഹിയർ, റൈറ്റ്? It should be 5 here. Fc is equal to 2f by 5. Fc is equal to 2f divided by 5. Okay, clear? So students, please let me know if you have understood so far. Please let me know if you have understood so far. Okay. Is this clear? So this is the object B. This is the object B. Okay, B is exerting a force. B is exerting a force on C, and that is equal to 2f divided by 5. B is exerting a force on B on the wall of C. That is equal to 2f by 5. Clearly, I am doing it very slowly. I am doing it very slowly so that you can understand the steps. Okay, in actual exam you won't have to take this much time to solve this question. You can do this very fast. Clear? Okay, so now it is a question of B applying a force on C. Now it is a question of B applying a force on C. Therefore now we can say mg is acting like this. Normal reaction will be in the opposite direction. Normal reaction will be in the opposite direction. Okay, so friction is equal to in the upward direction. Friction is in the upward direction. Friction is equal to mu times normal reaction. That is equal to, what is mu? What is the value of mu? Is given as mu, right? Yeah. Value of mu is given as mu itself. So mu times normal reaction is nothing but 2f by 5. We just calculated the normal reaction. If you push a wall with a force of 2f by 5, the wall will push you back with a force of 2f by 5. That is known as normal reaction. Okay, clear? Mu into 2f by 5. Mu into 2f divided by 5. That is friction. Therefore, this friction should be equal to mg to prevent slipping. To prevent slipping, the friction should be equal to mg. Understood? So mu into 2f by 5 should be equal to mg. Okay, should be equal to mg, and from that we will get mu is equal to 5. We have to find the force, right? We have to find the force. So the force required is equal to 5 mg divided by 2 mu. 5 mg divided by 2 mu. Okay, so answer is 5 mg divided by 2 mu. 5 mg divided by 2 mu. Clear? So please let me know if you have understood that question. You won't require this much time when you are actually doing this in examination, but I have explained it very slowly, step by step, so that all of you can understand. Okay, 5 mg divided by 2 mu is the answer. 5 mg divided by 2 mu is the answer. Okay, so just let me know how was the session. Was it helpful? Okay, did it clear your doubts regarding friction and all? So that is how we solve it. Okay, break down into parts. Draw free body diagram of each block. Okay, break it down, draw free body diagram of each blocks and solve it step by step. So this is an important question in laws of motion. This is a common question also. So the method, this technique is what you should learn. There is no formulas to learn. There is no complicated concept to learn. It is only F equal to MA. Every question can be solved by F is equal to MA. Okay. So we can wind up today's session here. We will have more classes like this for all chapters, for all subjects. Okay, live classes and high quality recorded videos in your DOPA app. So give your feedback, subscribe to the channel, subscribe to the channel. Also tell your friends about this opportunity. Okay, tell them to subscribe to DOPA channel. They will get this free content for all subjects. And if you decide to get the DOPA app, then you will have access to an entire course for NEET. Okay, made by doctors for doctors. So we are winding up the session. All of you can give your feedback. Okay, so thank you everyone for attending the lecture, and see you in the next class. Goodbye.